liquid metal to a die. The die shapes the handles cookie cutter style. Water flushes through the die. This cools down the zinc and it hardens into a handle shape with a lot of extra molding that they're going to have to get rid of. So now that they've cooled, it's safe to touch them and remove some of that waste. A worker snaps some of it off and tosses it in a bin for recycling later. And the handle shapes go into a separate bin. But there are still some little bits of waste on the handles called overflows. So a mechanically driven spinner tosses the handles around and knocks off any overflows that have been missed. It's a lot faster than picking off those little pieces by hand. A worker dumps the handle shapes into a bin. They're starting to look like something you could really hang on to. A similar die casting system is used to make knobs. But the knobs come in two interlocking pieces. They place them on a turntable and fit them together. Then a 4-ton hydraulic press presses down on the knob, and that pressure seals them. They pour a mixture of water and oil on the knobs to cool and lubricate them, while an automated machine drives a screw into the back of the knob. This makes a thread pattern inside of it, so it can be easily screwed onto furniture later. Now they plunge the handles into a chemical bath. The chemicals help to conduct electricity. This process is called electroplating. The handles are negatively charged. The brass particles in the water are positively charged. They attract and connect, and this causes the brass plating to form. They dip the handles into the chemical wash twice and then rinse twice. Next, they dump the brass handles into a vat of acid. This oxidizes it, blackening the finish to make it look antiqued. This brass pull has aged 100 years in just a few minutes. Next, they funnel the handles into a big round polisher. It's called a bowl vibrator. The handles are mixed in with steel ball bearings. The machine vibrates and the friction from the ball bearings polishes the handles. Now those antiqued brass handles have a shinier finish. Sometimes they use ceramic pellets in the polisher instead of ball bearings. They spray soap and water into the bowl to lubricate the handles and allow them to move freely. This gentler friction results in a different finish. The polish on the handles will be brighter. Now they put a handle into a clamp. With air pressure, it puts the squeeze on the handle so that it hooks into a back plate. When the pressure is released, the fit is snug. A front and back plate gives a handle a more elaborate look. They buff up a knob with a cloth polishing wheel that's mechanically driven. This process gives knobs and handles a certain gleam. It's the finishing touch. So now you have a handle on how furniture hardware is made. The Beatles wrote a song about lovely Rita, the meter maid. But try finding anyone else singing the praises of those uniformed patrols who ticket your car when your meter expires. Parking meters have been around since the 1930s, and ever since then, drivers, especially those caught without change, have been cursing them. It's time to unlock the mysteries of the parking meter and find out just what makes it tick. First, the low-tech part. The time limit label goes onto a zinc dome-shaped plate. Then a worker sprays lubricant onto various parts of the motherboard that contains computer circuitry. After he snaps the board onto the plate, he screws it in. Then he fastens another dome-shaped plate onto the back, sandwiching the motherboard between the two plates. The worker hooks the board up to the power source, the battery pack. And he tucks the pack into a special compartment so that it's secure. Then he plugs a programming device called an X key into prongs protruding from the motherboard. The key feeds software to the motherboard inside. When numbers appear on the screen, it's programmed. The next piece, called a smart chute, also has computer circuitry. It analyzes the coins as they fall through the meter. It can tell the difference between Canadian coins and American ones, and even recognize coins from other countries. He puts the chute into a protective plastic casing and plugs it into the protruding prongs that were used earlier to program the meter. The two boards make a connection and can now communicate to one another. He clicks another zinc plate over the coin chute and adds a stainless steel coin slot for added protection. This card is a radio frequency probe that detects how much money is in the meter as well as maintenance information. Just how good is this meter at analyzing coins? Well, a Canadian nickel and a British 20 pence are roughly the same size. Put in a Canadian nickel and you get 3 minutes. But try the 20 pence. Nothing registers. The meter treats it like a plugged nickel. The meters are now in an environmental chamber. This chamber replicates the most extreme climate conditions. It's a test to make sure they're ready for life on the street. Now it's time to make a lock. He puts a zinc alloy lock plug containing brass tumblers into a miniature lathe. The lathe spins rapidly on its axis while pressing against hard steel blades. The blades cut the spinning lock tumblers to the appropriate length. The result? A lock plug that has brass tumblers of different lengths that can't be opened without the correct key. Here, a worker places the lock barrel in a vise to give a better view of the lock system. As you can see, it turns easily with the key. But vandals beware. This lock is designed to be tough to pick. Next, he inserts the lock into